Right, so there was someone at the door in the middle of the last video, so we are going to have to continue from that point now. But it was a good point to stop the video because we had just said, okay, how we get the map estimate for W, and and then Y new could be W map transpose X new, and but this would still this will have the prior knowledge that we could incorporate on W, but still this would be a point estimate. This would just give us one value of y for a new value of x, right? Now for but here we having this posterior information, we can do something more general, and this is now really Bayesian, a Bayesian approach to linear regression. Introducing the prior is in some ways Bayesian, but a fully Bayesian approach would say that I will get a complete predictive distribution on y given x and the data by integrating out the w. So I'll say this is equal to the predictive distribution on y given x and the data. So this is y new given x new, and data is x1 to xn, y1 to yn. This will be integral of probability of y given x, n, x, d and w times the probability of w given x and d dw. So this is the likelihood of a new y given x, d and w. So this is a normal distribution with mean w transpose x and precision a, and this is the posterior on w given all the data that we had. So this is a mean, this is a normal that we computed here, right, with a mean mu and a covariance lambda inverse with mu and lambda given by this. And we have this, and then we can compute the product of these two normals. We do some linear algebra, and then finally we end up having also again the predictive distribution as a normal distribution with a certain mean u. So this is the predictive distribution of on y, which is like a real number. So this is a univariate normal with mean u equals mu transpose x, where mu was the map estimate, the mean of the posterior on w. Okay, so the predictive distribution on y has mean u equals mu transpose x, and precision 1 by lambda equals this guy. Okay, so the predictive transformation is also a normal distribution. It looks like everything is normal, right? Everything's normal. So the mean of the predictive distribution corresponds to computing the value of y using the map estimate for w, which was this, and this is x new, right? This is x new, and then this is the probability distribution on y new given x new and the data, right? And the key property that made us reach here through all this is that we were always able to get a quadratic, okay, first in w and then in y, to be able first in w and then somehow something went to 1 because it was an integral over w, and then we got a quadratic form in y, and therefore we could express it as a normal distribution in y. So this is Bayesian linear regression. It gives you a full it gives you a predictive distribution of y given a new x and the data, and that turns out to be a normal distribution, and you can find out the parameters, the mean and the variance of that, or the precision of that, in terms of the data. So for example, mu is coming from the data. All this is the data, and this is the precision values of a being the precision of the univariate normal on y. This is the model that you assume, and b being the precision along each dimension on the prior. So all this is the data and a and b basically, right? So that is Bayesian linear regression.